Hi, my name is Desmond Edagisi, and I'm your maths teacher. Today we'll be looking at the theme numbers and numeration. And under numbers and numeration, today we'll be looking at the topic sets. Under sets today, we'll be looking at sets notation. Let's go on and learn some more. In our class today, we'll get to learn that there are three forms in which sets can be represented. The first form is the roster notation. The second form is the statement notation. And lastly, we'll learn about the last form, which is the set builder notation. The roster notation. In the roster set notation, the set is defined by listing all its members, separated by commas, and then putting curly brackets around them. So we have an example. If we have a set of numbers ranging from 1 to 10, we'll list out our numbers using the strict enumeration method of our roster set notation, in which the members of the set are strictly listed out completely, as we said earlier, with commas separating each element to distinguish them one from the other. Let's take this example. This is a set of numbers that range from 1 to 10. So we have our curly brackets open. Then we have the list of our numbers 1, 2, 3, 4, up until we have our last number 10. And then we have the curly bracket again that closes up our list. This method is referred to as the strict enumeration method. Every member of the set is listed out. The next method we have is the pattern enumeration method. In the pattern enumeration method, elements with a clear pattern are shortened by only showing enough elements to describe our pattern, and then the rest are represented by what we know as ellipses. The ellipsis is a series of 3 dots. Whenever we see the 3 dots in sets, there is an indication within our list that there is a continuity. Take for instance, this same set that we had here. In the strict enumeration method, every member of our set was listed out. But in the pattern enumeration method, of course, we already know a pattern that a number is 1 plus the number before it. And so we have 1 plus 1 as 2, 2 plus 1 as 3, 3 plus 1 as 4. So we have a pattern. If that pattern is known, using the pattern enumeration method, we could simply write the first 3 members of our set as 1, 2, 3, and then make use of the ellipses. Again, the ellipsis tells us that there is a continuity. It continues from 3 and then ends with 10. So the ellipsis is a representative of our numbers 4, 5, 6, 7, 8, 9. And then we have our curly brackets, of course, that covers our set. So the pattern enumeration method helps us write our list in a shorter manner than what we would have had if we had to list every individual member. Another way our ellipsis is used is when we have numbers that range to infinity. That is, numbers that continue on and on forever. Let's take this instance. If we have a set of numbers with a pattern 3 plus 3 between each set. So we have 3 plus 3, which would give us 6. 6 plus 3 would give us 9, and so on and so forth. What if this pattern continued till infinity, or if it continued forever? Instead of listing the remaining numbers as 11, 14, 17, and so on, up until we have maybe 10 billion, 7 billion, 20 billion, and all of that, we'll simply make use of our ellipsis. So our ellipsis tells us here that within this set, this range of numbers continues on forever till infinity. we see a clear example here. Our set here is the list of even numbers from 2 up onto 20. So we have our ellipses in between the list of our numbers, and we have 6 as the last number listed before we have our ellipses up onto the range 20. So our ellipsis helps us again to write this out in a shorthand manner. The dot means goes on continuously till 20 in this instance. On the other hand, again, we see that our ellipsis may be used at the beginning or at the end of our list. It represents, again, a continuity in the negative direction in this instance, or a continuity in the positive direction in this instance. So our ellipsis again helps us to write out our list in a shorthand manner. And that's how we make use of our roster notation. Let's take some examples so we'll clearly understand how the roster notation is used in sets. Let's take this example. List the set of all whole numbers less than 10. Using the strict enumeration method, we would simply write our curly brackets and then list out our numbers 0, 1, 2, 3, 4, 5, 6, up onto 9. Remember, we're listing numbers less than 10. Between each number, remember, we have our commas to separate and to distinguish each individual element of our set. At the end of the numbers we've listed, we also close our curly brackets to indicate our roster notation of our statement here. Let's take another example. If we're asked to list the set of all even numbers larger than 4, we will see here again that there is no limit beyond our statement here. Larger than 4, it means that the number continues from 6, which is the first number larger than 4, up until 2 million, 5 million, 10 billion and above. In such an instance, again, we make use of our ellipsis after we've written out our open curly brackets and listed some of our numbers, which indicates a clear pattern. Remember, we have a comma after each number to separate and distinguish them. We write our ellipsis at the end of a few samples of our numbers, and our ellipsis indicates a continuity in the positive direction in this instance. It means that beyond 20 and so on, there are numbers that go on forever and ever and ever that has no end. Let's take a look at this other example. If you're asked to list the set of all the days in a week, this example would have no use for ellipsis. We'll simply list out our numbers because there are not so much. We have 7 days in a week, so we'll simply use the strict enumeration method by writing out our curly bracket open and listing each day as Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, all separated by commas to separate and distinguish them, and then we write our close curly brackets. This is the roster notation of our statement here. Let's take the last example. What is the set of all odd numbers between 0 and 100? Again, we'll write out our open curly brackets and begin to list our odd numbers between 0 and 100. If we were to list every individual number between 0 and 100, we'd have quite a long list. Probably would go on for maybe 2 paragraphs. But to make it short, we make use of our ellipsis. After we've listed a sample of numbers that clearly indicates a clear pattern, we go on to add our ellipsis and then add a few or just one number, which is the last number of our statement here, and then we'll close our curly brackets. The ellipsis again indicates a continuity between 13 and 97. indicating that there is a continuity and a range of numbers. So once again, this is our roster notation method. Let's go on to learn about our second method of representing sets. The second method of representing a set that we have is the statement or the prose method. When describing a set, it is not always necessary to make a list of the elements of our set. The statement or prose method can be used instead to simply define or describe the property or the rule that connects the members of our set. That is, to simply represent our set by writing the rule of the set in between our curly brackets. Let's take an example. X here is an example of our statement or prose notation method, and X is the set of all integers between -3 and 3 inclusive. M is another example, and M is the set of all letters in the English alphabet, and H is the set of all states capitals in Nigeria. So once again, we'll see the rules that bind our sets together listed in between our curly brackets. Okay, let's take some examples. So the statement or prose method could simply be written as, for example, the set of all prime numbers less than 100. Or, like we said earlier, we could simply just state out our rules in between our curly brackets. So P is the set of all prime numbers less than 100. Let's take a look at another example. The set of all players in Arsenal FC. If we were to list out all the players, we'll probably have like 25, 30 players, and that would be a long list. So the statement or prose method would simply write the given rule within our set here, which is all players in Arsenal FC, and it is written between our curly brackets. So our set is G is equal to the set of all players in Arsenal FC. And that's how simple our statement or prose method is. Also, if we have the set of all countries in West Africa, instead of making a list, once again we simply write out the rules as countries in West Africa, and we'll write them between our curly brackets. So X is the set of all countries in West Africa. If we were to make a list of all the local governments in Rivers State, that would be a long list. The set or prose method helps us to just write out our rule here, which is local governments in Rivers State, and we write that between, again, our curly brackets. So Z is the set of all local governments in Rivers State. Let's go on and learn about our third method of representing sets. The third method of representing sets that we have is the set builder notation method. The set builder notation method is used to describe a set by stating the properties its members must satisfy. To do this, we make use of some certain things. For one, we have the identifier of our set, which could be, for instance, the letter X. The letter X in this instance stands for a sample of the members of our set. So instead of listing every member of the set, we take a sample, which in this instance would take as X, to represent a typical element within our set. Next, we have a symbol, bar, or we make use of a full colon, and that stands for the phrase such that. Lastly, we have our rule, which the identifier must obey. Let's take a look at a practical example. So we have our curly bracket here. The open curly bracket stands for the phrase the set of. Next, we have the identifier. The identifier, like we said, is a sample of our element. That is, it's a representative of a typical element within our sets. And it represents the phrase all X. Next, we have a symbol, bar, or we make use of a full colon. So each of them are interchangeable. We could have a full colon or a bar. And of course, that bar stands for the phrase such that. Next, we have our rule, which in this instance is x is greater than 0. If we were to read all of this out combined as a statement, it would be the set of all x such that the rule x is greater than 0. So the full statement is read as the set of all x such that x is greater than 0. Let's take a look at some examples. If we're asked to write the set builder notation for the set of all real numbers except 3, our notation will be written as this. That is, our open curly brackets, which is the set of all x. X, of course, we said, is the identifier, which is a representative of a typical element of our sets, such that x is all real numbers with the exception of 3. So we have our rule as